This video is for the Module 8B review for Semester 2 final. I'm just going to write a couple things that are important to remember about this unit where we talked about radicals. So one thing to remember, there cannot be any radicals in the denominator for it to be considered fully simplified. There also, in order to get rid of radicals a lot of times, we had something like this in the denominator. So what I do is I multiply by the conjugate, okay, to get rid of it. So conjugates are the same exact thing, but I just change the sign in the middle. When we're solving, we're going to get the radical by itself. So we're going to isolate the radical, and then apply a power. So if it's a square root, we would be squaring it. If it's a cube root, we would be cubing it. Okay, and then the other thing when we are solving is always check for extraneous solutions. Okay, and then when I have a power, something like this, remember I can rewrite that as the nth root of x to the m, or I can also write it as the nth root of x and then in parentheses raised to the m. So those are all equivalent. This would be exponential form, and this would be radical form. Okay, all right, so we're going to use some examples here to revisit some of the properties. So let me zoom in maybe just a hair more here, you guys. There we go. Okay, so I'm going to get rid of this radical in the denominator by multiplying by its conjugate. So it's 2 minus the square root of 5, and we're going to multiply the top and the bottom by that. So 2 minus square root of 5. Okay, so on the top I'm distributing. So 8 times 2 is 16. 8 times negative root 5 is negative 8 root 5. Negative root 3 times 2, negative 2 root 3. And negative root 3 times negative root 5 is a positive root 15. Over, this is difference of squares, so it's the first term squared minus the second term squared when I put it back together. So I'm going to simplify a little on the top. I actually cannot combine anything on the top, so that stays the same because all those radicals are different. But underneath, I'm going to get 4 minus 5, which equals negative 1 for my denominator. So I have this whole thing divided by negative 1. Which is just going to change all the signs. Okay, and so since my denominator was negative 1, it changed all the signs, and I just wrote it without the denominator of 1. Okay, here I want to pull out any perfect factors. So I want to think about things that go into 72 that I can take the cube root of. So 72 is the same as 8 times 9. So 8 times 9, so 2 cubed times 9. There's nothing that goes into 9 that I can take the cube root of. Y, I could break into y to the 6th and y squared. The reason I'm doing that is because I can rewrite y to the 6th. And z to the 4th, I can break into z to the 3rd and z. So when I'm breaking apart these exponents, I'm thinking about factors of 3. So if cubed root and cubing cancel, the 2 would come out front. Okay, the 9 stays underneath. Y to the 6th, so the y to the 6th part, cube root of y to the 6th is the same as y to the 6 over 3, which equals y squared. I can do, and then the y squared stays underneath. Z to the 3rd and cube root cancel, and it's just a z. And then I have one lonely z underneath. So this would be pulling out all those perfect factors. Okay, this one is the same as 4th root of x over the 4th root. I'm going to rewrite 8 as 2 cubed. The reason I'm doing that is because to get rid of this radical of 4, I need things to be to the 4th power. So if I write it as something to the 3rd power, I only need to multiply by 1 more 2. So I'm going to multiply by the 4th root. I need 1 more 2 to get it to the 4th power. This is y to the 1st, so I need 3 more y's to get to be the 4th. So we're going to multiply the top and the bottom by the same thing, so that we're really just multiplying by 1. I can multiply those together because they're both under a 4th root. So we've got 2xy to the 3rd over. Now these are going to be just a 2 and a y. The 4th root of 2 to the 4th and y to the 4th turns into that. Okay, last example we're going to solve here. So my radical is already by itself, so to get rid of the radical, we're going to square both sides. So I've got the square root is gone, and I'm left with 3x plus 7 equals x plus 3 squared, which remember that is this. So if I distribute twice, I get x squared plus 6x plus 9. Okay, so don't just say it's x squared plus 9. You miss out on that middle term if you do not square that correctly. I'm going to set this equal to 0 since it's a quadratic. So I've got 0 equals x squared plus 3x plus 2. So I need numbers that multiply to be 2, that add to be 3, so 2 and 1. So my solutions would be -2, -1. Okay, so remember we want to check for extraneous solutions. So we're going to take each of these and plug it back into the original equation. So I'm going to plug in, let's start with -2. So I've got 3 times -2 plus 7. I'm checking, does that equal -2 plus 3? Okay, so I get -6 plus 7, which is 1. Here I get 1, so that one checks out. Okay, check -1, so we've got 3 times -1 plus 7. Does that equal -1 plus 3? Okay, so here I get -3 plus 7 is 4, -1 plus 3 is 2. So actually, both of these work. So if one of them did not work, then I would not list it as one of my solutions. Okay, that's it for this video. Thanks for watching.